So in this video, we're moving on to slightly harder examples. Yes, it looks more complicated, but the technique is exactly the same as the previous example. So the idea here is, well, we're looking at this expression. I'm not going to read it to you, it's too long. But the one thing I want you to notice is that we have square roots basically on everything in sight. So using the quotient and product rules for rational expressions, we might be able to combine these all into one giant ball of radical. Okay, or everything that you see inside the radicals gets put under one radical. Okay, and the reason we'd want to do that is because if you notice in the first radical we have m's and n's and powers of 2. We have an m in a power of 2 inside this guy. We also have more m's and n's inside this radical. So probably if we were to combine this all under one giant radical, a lot of cancellation will happen. And that's what we're hoping for here. So how do we go about doing this? Looking at the expression that we had before, I'm going to use the product rules and the quotient rules simultaneously, all at once, so that I can get everything under one giant radical, okay? And the idea is to cancel as many of these m's, n's, and powers of 2 as possible. So I have one giant radical, because it's all the same square root, they're not different powered roots, so we can do this. We have 8 times m to the 4th times n cubed times 4 times m squared, all over 32 m to the 5th n cubed, and that's what we have so far. All right, combine everything that you possibly can here. So we have an 8 and a 4, so those combine, and what does that give you? 8, 16, 24, 32. That's awesome. So we have a 32 in the denominator and in the top. Those will cancel. We also have we have 4 m's here, and we have 2 m's here. So those will multiply and give us m to the 6th. We have no n's on top, but that's okay. We'll just rewrite it. So we have 32 m to the 6th times n cubed, all over 32 m to the 5th times n cubed. All right, so notice that just because we combined all these radicals into one giant radical, you can see a lot of cancellation that's about to happen here. So the 32's go away. The n cubes go away completely. So I'm left with, well, if I have 6 m's on the top and I have 5 on the bottom, 5 of those m's are going to divide away, leaving us with only 1 m on the top. So canceling out as many m's as I possibly can, this gives me just a square root of m. And that's completely simplified. We can't break down this m any further. So at this point, we are done with this example. And if you found this example helpful, please smash that like button. I'll see you in the next one.